Okay, so in part 1 and part 2 of the player class, we've described that why the class implements mouse listener, the instance variables, with this all dice thing being a tricky little step that is used to tell the player when to place the dice, when to not ignore a mouse click. We've described the constructor, which initializes the instance variables. We've described the scorecard is full and the paint method in detail. I've talked about the place dice method. Get upper and lower totals will be methods that you write, mouse events. So we ignore the mouse release, clicked, entered, and exited. Those are just stubs, but mouse pressed needs some explanation. So mouse pressed is working a little bit in conjunction with place dice, is definitely working with the all dice variable and the game. So these several things work together, making it a little bit tricky. So let's review in the game. Whenever the roll button is clicked, if the roll count is equal to 3, it takes the player whose turn it is and places the dice. So it's giving that player dice. So doing that basically just stores those dice in the all dice variable for that player. Okay? So that's the all dice variable. So that all dice variable, it starts out at null, and then in the game, on the third roll, whichever player whose turn it is gets a copy of the dice and stores them in the all dice variable. Now remember, a player implements mouse listener and is listening to every mouse press. But it should ignore many of them. And until it has some dice to place on the scorecard, it should just ignore all mouse presses. And so that's what this does. It says if all dice is equal to null, just return, just quit and do nothing. So when the mouse is pressed, if it doesn't have any dice to place, it just quits. Only one player will have the dice, and it'll only have the dice after the third roll. So assuming that it does have dice to place, it's going to calculate a lower and upper limit. So that click has to be in a certain location. If we look at the game, say it's player 1's turn, we want to ignore any click that is outside of that player's column, any click that is outside of an appropriate category. So this upper and lower limit, if the click has a Y value that is above this line, we want to ignore it. If it is below, or I should say between this line and this line, we want to ignore it. If it is below the line of chance, we want to ignore it. If it's to the left of this line, we want to ignore it, or if it's to the right of this line, we want to ignore it. So lower limit. This is going to calculate the left edge because it's using the index. 250 is the left edge of the first column. And its index, so if its index is 0, then 70 times 0 is 0. The lower limit is the left edge. So that's player 1. Player 1 has index 0. Its lower limit is the left edge. And then the upper limit is just the lower limit plus 70 because the column width is 70. And then it says if get x, if the mouse event's x value is less than the lower limit or its x value is greater than the upper limit, just go ahead and return, quit. So it quits if it doesn't have any dice to place, and it also quits if the click is to the left or right of its column. Now it's got to figure out whether it can place it in the upper section. So it gets the y value if that y value is greater than 60 and less than 264. So 60 is the location of the top line, and 264 is the location of this bottom line here. So if it's greater than 60 and less than 264, meaning it's below this line and above this line, we already know that we've got dice to place. We already know that we are between the left and right edge. Now we've found out if we are below this and above this, then we want to place in the upper section. Now we've got to figure out which category of the upper section. That category is determined by our index. So we get the y value, and this calculation, that y value minus 60, because 60 is this top edge, divided by 34, because each category is 34 pixels tall, and plus 1 because the smallest category is not 0 but 1. So this will calculate the index of the appropriate category. If they click inside of aces, this expression will evaluate to 1. If they click inside of 2s, it'll evaluate to 2. If they click inside of 3s, it'll evaluate to 3, and so on, all the way up to 6. So this is a calculation that gives us the appropriate index, and then we write a method called place in upper section of that index. And so that's going to do all the work of place in the upper section. If the y value is greater than 358 and it's less than 596, so 358 is the top of this bottom section, okay? And 596 is the bottom of the lower section. So if it's between the top and bottom of the lower section, then we're going to calculate an appropriate index here and place it in the appropriate category. Now this is a little bit trickier because we couldn't just use an array. Each one of these calculations is a little bit different. So I've used a construct here called switch case. The way switch case works is you calculate your index, okay, and this calculation is similar to the other calculation, except that I'm going to use an index of 0, so I'm not adding 1. I still subtract 358 because 358 is the top of the lower section. I still divide by 34 because each one of these is 34 wide. Because index is an int, it'll go ahead and actually everything in here is an int. It'll go ahead and throw away the remainder. So this calculation is an integer. It throws away anything that is a decimal. It'll work to calculate the index. And this switch statement is like a bunch of if-elses. It's switching on an index. If that index value is equal to 0, it'll execute case 0. If that index value is equal to a 1, it'll execute case 1. If it's equal to a 2, it'll execute case 2, and so on, all the way for each cases. And so this is the way the switch case works. You say switch, round brackets, something that holds an integer value, and some squiggly brackets. Inside of the squiggly brackets, you use the keyword case, some integer value, and a colon. The code that you want to execute for that case, for us, I'm just going to call a method, and then you have a break. It's important to have the break. What the break does is it exits the switch case. If you don't have a break here, say I remove that break, then when the int is 0, it'll execute this code and then go down to the next one, also executing this one and then seeing the break. I want to isolate and separate each case, so I'm going to break out after executing the code. The break exits the particular case without executing any other case. So it goes to the first case when you have an int value, it'll jump to the appropriate case. It'll begin executing that case, and it'll execute every case after until it gets to a break. And so I put a break after each one because I want each case to be exclusively separate. So I've said case 0 is the 3 of a kind. Case 1 is the 4 of a kind. Case 2 is the full house. Case 3 is the small straight. Case 4 is the large straight. Case 5 is the Yahtzee. And case 6 is the chance. Okay? So now the thing left to do is explain each one of these methods. Place in upper section, place in 3 of a kind, 4 of a kind, full house, small straight, large straight, Yahtzee, and chance. So I've used functional decomposition because it was easier for me to think about, okay, let's just, in this method, it's complicated enough to figure out what those x and y values are, and then figure out what thing I have to do. And then the thing is to just place those dice into the appropriate category, calculate the score for them, and store the score. And so I just wanted to think about each one of these different categories separately, so I made them separate functions. I will explain in the next video the different the different methods that place the dice in the appropriate category.